Hi, everyone. Thank you for joining us for today's webinar, Testing Design System Changes Across Your App, with Tyler Krupicka, Senior Software Engineer at Intuit. So before Tyler kicks off, I'll just give a short intro. Tyler, as I mentioned, is a Senior Software Engineer at Intuit, where he works on core frameworks that power the interview-style tax preparation experience in TurboTax. His team's UI components are used to display hundreds of millions of screens to customers every year. He's also an accessibility champion at Intuit, helping teams across the company make their experiences more accessible for all users. And of course, you can follow Tyler on Twitter. So without any further ado, Tyler, the stage is yours.
Thanks, Adit. I'll go ahead and get started. And I'm going to use some live transcription through PowerPoint. Hopefully that will help people follow along as I'm speaking. And hopefully it'll be more correct than wrong. So I'll go ahead and get started. Thanks everyone for attending the session. This is the Art of the Design Refresh. I'm going to be talking about how we use design systems at Intuit to have a consistent experience, and specifically how we test those changes before they go out to production. And so a little bit of background about the place that I work, Intuit. We're the makers of three main products, TurboTax, QuickBooks, and Mint. TurboTax is tax software, tax preparation software that is primarily used in North America. QuickBooks is small business accounting software, and Mint is a personal finance application. The headquarters for the company are in Mountain View, California, and we have about 9,000 employees serving 50 million customers worldwide. I'm actually not in the Mountain View office. I'm in San Diego, California, but I do get to go up and visit sometimes. And just a little bit about me, like we already discussed a little bit, I work at Intuit, and I've been doing web development there since about 2015, and I work on the player/design systems team. And so a lot of my job is working with UI components, pieces of the interface that get used throughout our products, and tools around them and testing around them. On the job, we primarily use TypeScript and React, but I'm also pretty familiar with Vue and use that quite a bit as well. Like I said, I'm located in San Diego, and I'm a level 2 accessibility champion, which probably doesn't mean a whole lot to most of you, but Accessibility Champions is a program that Intuit puts on that basically encourages employees to take some extra responsibility for ensuring the accessibility in our products is really high standard. And if you're ever interested in learning more about that program, our employee Ted Drake often gives talks at accessibility conferences about it. And so today I'm going to be going over a bunch of different topics about design systems that starts really broad, but will get a lot narrower. So at the beginning, I'm going to be talking about what are design systems, how they relate to the work I do, and kind of the different testing criteria we have for our design systems. And don't worry if that seems a bit broad. By the end, I'm going to get down to specific actions that we take to test and have confidence in any releases that we're doing for a design system. So we will get there, just hang in there. And I will go ahead and get started. So what are design systems? Pretty broad question. But I think when I ask this question to a lot of people, the first thing that comes to mind is some of the largest design systems that exist out there. You might be familiar with things like Material Design, which is Google's design system, or the Human Interface Guidelines, which is Apple's design system, or Bootstrap, which is a set of UI interface components / CSS library that has become really popular on the web. And for a lot of people, if that's your idea of a design system, you might wonder, why do I need a design system for my application? Why are people talking about this more frequently now? You know, if my product isn't an operating system like Android, is that something I really need? And hopefully by the end of this, you'll understand where there's a lot of utility just for a product itself. And really, when I start to talk about design systems, I think of it as really two pieces. There's a design portion, which is taking apart common components and patterns that get used throughout your product. And there's a code portion, which is building that, either in CSS frameworks or in React or some other way that teams can reuse the same code and the same design throughout the application. And so to go into more detail about that, on the design side, what I really see is a consistent voice for your product. So at a foundational level, those are things like typography, colors, and spacing throughout the application. But then it gets broader into a lot of the UI pieces. So if you're going to be building forms into your product and you have things like buttons and inputs, all of those having the same consistent design. If you have navigation in your application, so a top header or a sidebar, that being consistent and following design patterns. And that also goes into things like making sure the graphics in your application and animations are all fairly consistent. And I'm sure a lot of you are familiar, like when you go use products, often they do follow this. There's a lot of consistency in there. If you had a product where every single input or button was built by a different person and looked slightly different, you could imagine it would be really difficult for a customer to get used to how the product looks and all of the interactions that are common in it. And so a design system really helps you take those base pieces and document them really well and make sure you have this level of consistency across the application. And then on the code side of that, it's really, really helpful from a code reuse standpoint to build your design system as some sort of central piece to your application. So if you're building and documenting these components individually, you can test them all individually. If you just have your button as one individual piece of a design system, you can test that a lot more thoroughly on its own than individually in each screen in the application. And then because you're taking this piece of the design and bringing it out and reusing it everywhere, you can build all of these experiences without duplicating any code, and you can address any issues or make design changes centrally. So, because we have one button throughout the entire application, if we decide to change what that looks like, we can update it one place and then see that update everywhere in the application as well. So there's a lot of benefits just to how you can organize the code for your product using a design system as well. And so in three bigger points for that, you can reuse code that increases productivity, and you can create a consistent voice for your application. And so how does that work with TurboTax, the product that I work on? And what kind of problems are unique to our situation, and why is design system a good solution for us? So for those of you unfamiliar, TurboTax is a tax preparation do-it-yourself software primarily used in the United States and Canada. And it's used by about 30 million people a year to file their taxes. And one of the main components of it is what we call an interview style user experience, which is basically you're not filling out all of the tax forms as forms in your browser. You're getting asked individual questions that pick out what forms you actually need and fill those in for you behind the scenes. So it's more of a question and answer, single question per screen type of user experience. And where that gets a little bit complicated is there are thousands of possible screens that a user can encounter based on their tax situation. And so this really differs from, I think, a lot of products where if you get to the complicated end of most websites, you're probably thinking hundreds of screens, but we have thousands, even like tens of thousands of possible screens that a user could see. And those screens can range from a single question, like something here on the bottom right that's just multiple choice, or it can be a piece of a form, like personal info up above. And so in order to make sure all of these thousands of screens have a consistent user experience that is the same all the way through, even with different teams working on it, even if that screen hasn't been touched in the last year, we use a design system, and the design system contains about 50 UI components that are needed to run the experience. So those are things like text, or these tiles, multi-select, or radio buttons. And we also have about 500 mocks of what common screens look like for testing, so that we have some of those patterns available without having to necessarily go straight into the product. And so an example of what a typical minor design refresh looks like for us, last year we were actually going through and trying to improve the contrast in the application. And so some of the things we did were we were updating typography and the color of our buttons to have a little better contrast with white text, updating the color of our links to have a little bit higher contrast. And you can imagine, like, text and button and links, these are things that almost every screen has. So there was a huge amount of screens impacted, but at the time when these refreshes were happening, there was maybe 4 people on the team. And so we really don't have the capacity to go through and manually check all of these thousands of screens to ensure that the changes we made had the intended effect on all of these screens. And so that kind of gets into what things we look for when we're testing and how we want to approach it given these constraints that we have for our product. And so at a broad level, we have 4 main categories of things that we're testing for with any individual change for the product. The first is functionality. These are things you're probably familiar with if you have worked in the web testing space. So things like unit tests, integration tests, making sure that the components you have work in a bunch of different browsers, that they work on a mobile device, and we can have some automation to help with that. We also do visual testing. Since what we're changing is often very visual, we want to know not just how the change is going to impact the component itself. So, in the case that we're making a change to buttons, not only do we want to know, did the color change or the size change at a button level how we expect, but also when we put that in pages, how does that change the spacing between things? If we have pages with a lot of buttons in between sections, does that condense the page too much? How does that affect the product end to end? And then we also look at things like performance. So we want to make sure that all of the code that we're producing, the CSS and the JavaScript and the HTML, is all as minimal as possible so that it takes less time for our users to download and jump into the product. And then the last big piece is accessibility. And with that, we're looking to make sure that our product is usable to any customer who tries to come in. So whether or not you're using a screen reader, whether or not you navigate using only your keyboard, everything should be well labeled and easy to navigate. And so the first piece, when we were working on our design system, in kind of providing structure for how we were going to document and test everything, was we needed to have a good documentation site. And so some of you may be familiar with this project, but Storybook is a really fast-growing open source tool for creating a documentation site for components. And it's gotten really popular because of projects like React and Vue that encourage people to build interfaces in small components. And so for each of the components that you're building, you can create an interactive story, is what it's called, which is basically just one use case for that component. You can even create complicated ones. So you could have a set of your storybook that is, full page mocks as well, piecing together all the components. And so one thing we started with was moving all of our component documentation into this project and creating examples that make testing easier. So one thing we always like to do is test focus states using our keyboard. And so we might add buttons above and below different interactive elements so that we can quickly tab onto the page, tab above and below it, and make sure that focus works. We can also do things like if there's a component like a tooltip that only shows up when somebody hovers on something, that might be hard to test with automation. Those kind of things that require interaction to appear are often hard to work with. And so we can actually make a story where we always apply the hover to it so that it's easier for our automation to go in there and interact with that particular component. And so then the other thing we try to do as much as possible is start with automation. So if we're making changes in the central system that might impact thousands of screens, and we don't have the capacity to manually go and test all of those, we need to rely heavily on automation. And hopefully this resonates with the group who are attending this webinar. But on top of just using automation, we also try to have principles where we want it to work with the development workflow. So for example, if we're going to do tools that automate accessibility or performance of visual, we want to make sure that we can report that status back to GitHub, which is where we do our development, and that we can actually let developers know when a change impacts any of those things before we even start looking at doing manual testing, or we start looking at merging it in and preparing for release. And this lets you catch issues as early as possible. And hopefully, if you have a solid baseline of testing that applies across the design system, it will help you focus on just the places where you really need to do manual testing or you need an extra touch to make sure that the high impact areas are high quality. And the last thing that is really helpful for us is really dog fooding our system. So it's really easy with a design system to just focus on building the individual components and not necessarily worry about how they all interact. But what our team has found is actually taking the time to create experiences using your components. One, helps you just understand, what it's like building pages with it, and that's a good practice for even just making sure your system's easy to use. But on top of that, if you use tools that other teams are going to be using to build product experiences, if you're recreating mocks, these all help you test more complicated interactions with the components. So, for example, it might be a little bit hard to see with just a static image, but this kind of table inside of TurboTax actually slides down and expands. And there's a lot of different things that teams could put inside of that, different components that slot in there to show data or jump off to other parts of the application. So having mocks that kind of showcase that with different configurations of what teams might do help us make sure that any changes to the components that go inside of it still work properly. And so now I'm getting into some of the more exciting portion of this, which is a step-by-step walkthrough of what it looks like for us to test end-to-end some experience that we're building or some design change. And so the scenario I'm going to use is really simple. We're just going to be saying we're going to update some buttons to a new design specification. And you might be inclined to say, oh, that seems like a small change, or that's something that might not happen super frequently. I think I've updated buttons probably 3 times in the last year or something. So for me, that's a pretty routine change. And if I'm going to be making this change, though, it's one that has a high impact. It flows through the entire application. Our buttons can look a lot differently than just this example on the right. A button can be have a transparent background and just be an icon, or a button can just have a border around it and not have a full fill color, and they can be placed all over the place. So we need to make sure that this kind of change is going to not have any impact that we didn't expect when it gets rolled out to the product. And so the first piece of that is going to be our unit and integration tests. And if we're talking about unit and integration tests for just the component, just inside of our documentation site like Storybook, those are actually going to be pretty simple. There's not a whole lot we can do. We can test, can the button be pressed and interacted with? Does it allow you to press the Enter key or common other keyboard interactions? If I add extra attributes like ARIA attributes to the React component, does that make it onto the actual button? Because in React, you might have to whitelist certain properties. Things like, can I place an icon in it, or some of the other configurations I talked about. And so for us, when we're doing these unit tests, we have a fairly standard setup. We're using the Jest test runner, and we use a lot of WebDriver IO or Selenium. Some teams in the company also use Cypress to run these tests. For my team, I don't believe Cypress supports Safari yet. And so for our team, we want to make sure that our automation also runs on Safari, since we have so many users on iOS, and we want to make sure that everything works well there. But that's fairly straightforward. We use the same setup if we are going to be testing a full page mock for things as well. So we'll also use Selenium automation to click through. We'll also write tests that navigate the page using a keyboard, try different inputs, etc. But that's really our baseline for, can a user make it through the product and interact with everything in the way we expect them to be able to interact. And so the next big piece is accessibility. And I've mentioned this in a couple of slides previously, but the baseline for that is a project called Axe that we use a lot. And for those of you who are unfamiliar with Axe, it's a static analysis tool that helps you catch accessibility issues or pieces of your page that might not meet the different ARIA accessibility specifications that exist. And one of the base level things that we can do visually for our design system is we can do contrast checking. And so what Axe will do is it will go and, like, if we have a button, it will find the background color of the button, and then it'll find the text color of the button, and it'll actually look up and say, what is the contrast between these two colors? Is it high enough to where somebody who has, maybe a little bit more difficulty seeing, is the text still easily readable to them? Is the text too small, or is the weight really thin? Those kind of things. But another big thing we really use it for is testing that everything can be labeled properly or has the right ARIA attributes if needed. So sometimes we need to re-implement components that aren't exactly the native HTML attribute. So for some of you who've implemented some components before, you might have tried to say implement a radio button or something, and you you pull up, the normal HTML input type radio, and you find that on a bunch of different browsers, the input doesn't really look the way you want. You have a design that maybe you want the little circle in the radio to animate outwards or something, and that's not possible in a bunch of browsers, or some browsers allow you to style that, but others don't. And so what you end up doing is you end up hiding the actual native input and instead place your own kind of custom implementation. And that's great because you can have a lot of flexibility in your design. But when you do that, you need your component to have the same interactions that the native element has as well. So if somebody's coming through with a screen reader, it all still makes sense. Keyboard interaction still makes sense. For those of you who haven't played around with the keyboard too much, something like a radio button, actually the interaction for it is a space bar and the up and down arrows. So if you're, not super familiar with that, you might just turn on enter or something. And so Axe will help you find and make sure that your new input is still labeled properly and has some of those base attributes that are needed. So it's really helpful baseline. And then there's also a manual component to accessibility testing, which is using some of the screen readers like JAWS and VoiceOver and NVDA on different operating systems, testing the keyboard navigation. And one other piece that we'll test for very frequently is reduced motion support. And this might be something that's new to a lot of people. It's certainly actually new to me. I think we've only started really using that in the last year. But actually browsers now have an option where if a user sets a setting in the browser or in their operating system that they might get motion sickness from a lot of animations, you can detect that in your product, in your web page, or your native application actually, and tone down the amount of animation that you do. And so we'll frequently do that to shorten the duration of animations, or maybe change something with a lot of movement to something that fades in. But that's something we'll also be looking for testing with our components. And then another piece is performance. And I mentioned this a little bit earlier, but bundle size is something that's pretty important to us. So now that we're building these components and they're a blend of JavaScript and CSS, there's a serious possibility that we could accidentally make the component a lot larger than it needs to be. If you think about, the size of a button, if you just use the native HTML button and a few lines of CSS to style it, you're talking about hundreds of bytes or something for your component. Once you start bringing in frameworks like React and start doing some more dynamic CSS things, you can start slowly increasing the size of your component. And another thing we've had issues with over time is in the JavaScript ecosystem, it's really common to go and find libraries to help with different pieces of your project. So say, for example, we're building a table, and our table is going to be full of data, and we want some nice interactions where a user can filter or sort that data. And so we might use libraries like React Table or something like that to give us that functionality. And if you're not careful, you can import a library that might make the size of your component 3 or 4 times larger. So, there's a trade-off there. Is the functionality that library is giving you worth the extra time it takes for your application to load now? Because, we always try to come in with the assumption that a customer may not have the best internet connection. Maybe they're on a mobile device. And so if it takes an extra second or two for the page to load just for that library to come down, that's really not ideal. So we have a bunch of automation to kind of help us track that. One make sure that the component itself is a certain size that meets a threshold that we're looking for, but also that any future change to the component doesn't accidentally increase the size a lot. And one thing we'll see over time often is we use a library and it might be pretty small, and everything looks great. And then at some point we go and we run a series of updates, and we take a library from version 1 to version 2. And in that time, that library has doubled in size. And so, we can catch that, and maybe we go out, if it's an open source library, and we try to contribute back to make it smaller or things like that. Or maybe we switch off the library. But those are all considerations that we go through. And then the manual piece of performance testing is how responsive is the whole page. Like for a table, if we're doing pagination and I passed in 1,000 rows, does the table lag a little bit? Can I scroll smoothly? Those kind of things. And we haven't found a phenomenal way to automate that. We can get some performance statistics out of React about how things rendered, but that is often a bit more manual still. And then there's a visual component, and that's something that's obviously huge for a design system where you're making components that are largely the visual user interface. And so we use Tools, ultra-fast grid. We've been using that since it was about in beta. But for any of our components and any of the stories that we build in Storybook, any of those examples, we will screenshot test those in between changes. And we'll do that across browsers, which is one of the really handy pieces of Grid, is that we can have a screenshot test in Edge, Chrome, Safari, and we can also do that at different breakpoints. So we can make sure on the smallest screen size, is everything responsive the way it should be? Will it look good on an iOS device? And then on the full desktop screen size, does everything take advantage of the space as well as it can? And so that really helps us gauge that any individual change is, having the necessary or impact that we expected for any of those components. And in addition to doing all of these tests at a component level, we'll also do these at the mock level as well. And so we have all of these example screens that are built using the UI components. And anytime we're testing a change, we'll first test everything at the component level, make sure it looks good, but then we'll also roll out all of those changes to the mock level. And that allows us to first look at, okay, the size of the button got a little bit smaller here. That's maybe what we intended to do, but everything looks good. Icons still work. When I pull that into a page, though, it may have some changes I wasn't expecting. So it's probably pretty hard to see in the screenshot, but there's actually a button in the middle of the page and a couple other along the way. And so because each of those got a little narrower, the whole page ended up shifting slightly, and we actually removed some space in between the different sections of the page. And so maybe that's fine if it still meets our spacing guidelines, or maybe we need to adjust our spacers accordingly to make sure we have uniform spacing. And so this also applies for ACS, scans, and accessibility. We'll be testing beyond the focus of individual components, the focus as you navigate through an entire screen. We'll be checking with ACS that labels actually show up where they need to show up, that a screen reader can use it. We'll be checking that the performance of the entire screen as all the components work together is good. But one thing that really helps is, again, that visual regression testing. So if I'm making a change to buttons and we have these 500 mocks, I know that almost every screen in our product has a button of some sort. And so if I run a visual change against that, I can, benchmark, I think that this change shouldn't impact every screen or a lot of them. And so if it comes back and says, well, only 20 screens changed visually, then I probably did something wrong. That's not reflecting what I expect. At the same time, an inverse of that is if I'm making a change to maybe a bar chart component that we have that's only used on 3 or 4 screens, and I put that in and run them against our mocks, and it comes back and says, hey, 200 screens changed, and I go, wait a second, that's way above, and then I can start to drill into some of those screens and going, okay, maybe some CSS classes that I am changing weren't scoped properly or something like that, and it ended up changing spacing on other screens. And so that really is the surface level sanity check for any individual change. And then from there, we can jump in and start looking at screens that change the most and start stepping in with manual testing and reviewing each of those different things. So that's kind of how we're able to take some small change and benchmark it against the whole larger application and make sure that the change is having the intended effects. And so going through all of this, you might be thinking, okay, so I mentioned some tools throughout there that we were using, things like Axe or Applet tools, but I didn't really go over the nitty-gritty of how we wire that all together. And if you're actually interested in building a design system, I'm happy to let you know that we've actually taken a lot of the tools that we use, one for documenting our components, but also for testing our components. And we've open sourced most of our configurations. So if you're looking to build a design system and test it, maybe these tools are helpful to you. And the first one is the design system CLI. And so if you are familiar with Create React App, or maybe some other tools that help you quickly set up a default configuration for building a web page, DSCLI is like that, but it's a pre-configured version of Storybook. And that includes a lot of our tools for breaking out each component that you're building into a separate NPM package with templating so that every time somebody creates a new component, it all starts from the same place. We have things like TypeScript support, and the bundle size tracking that I was talking about for performance testing components, that actually comes from the design system CLI. So if you build a design system using this tool, it can actually go and find all your components and bundle them and give you statistics in a table about how you're doing performance-wise. And one of the other really cool features of that is we can actually create a size change log for every component over time. So for any component, we have this change log file that you can open up and look at for each release. How big was this component? And you can kind of start drilling back to if a certain change caused the component to grow too much. And so this package is free and open source. It's on GitHub's, on our Intuit page on GitHub. So GitHub Design Systems CLI, and I have a link on the last slide for that. So, and we also have an example design system as well. I can try to share some of these in the chat as well. And the second project we have is Proof. And Proof is really what allows us to do most of our testing capabilities. So by default, if you're using Storybook and you're taking your components and documenting them in these individual stories, there's actually not a super easy way to go and automate testing that. You could probably open something like Cypress or WebDriver IO and just try to automate UI testing by clicking around in the sidebar for Storybook, but that's really not ideal. And so what we made is a test runner called Proof that basically lets you write UI automation tests that target specific stories in Storybook. And so what it'll do is it will actually go into Storybook and pull out the URLs for all of your stories and handle all of the navigation and configuration for you. And so with that, you can use WebDriver IO and start automating, clicking around and interacting with the components. But you'll also notice on the slide that it says it's a tappable test runner for Storybook. And for those of you that are unfamiliar with tappable, it's a plugin system that a lot of JavaScript frameworks use, the most popular one being Webpack. And so what that means is you can write plugins for this test runner that execute at any part of the testing process. And so what we can do is we can register a plugin for Axe, which we've done, that anytime a test executes, at the end of the test, it loads Axe into the page, runs Axe, and then gets the report of any accessibility violations and compiles that into a report that is saved at the end of the test suite. We can do the same thing with Applitools and the ultra-fast grid, where any of the tests that we run, we can also go and have Applitools upload that particular story to Grid and start visual regression testing it. And so it's a really handy workflow for us where anytime we want to add some extra steps to our testing, we can just add a plugin. And all of this work is completely open source. So if you have a Storybook that you currently work with and you want to get up and running using WebDriver on it, or you want to just get a quick Axe report, or you want to run ultra-fast grid against it, you can definitely jump over to the Proof documentation and get started with that. Hopefully that greatly simplifies the process for you. And I'll also, on the last slide, have a link to the Intuit GitHub where you can find that. And so with that, I think that concludes most of my overview for everything. So I'd be happy to open up for some questions if anyone has any. And here on the slide, github.com/Intuit is where you can find the DSCLI and Proof projects. And then if you're interested in learning more about Intuit, I also have a link here.
So first of all, before we go into questions, and we do have some, I just wanted to mention that any links and assets that Tyler, if you want to share, of course you can send it to me and I'll share it with everyone in the follow-up email where they're getting their link to the recording. So that shouldn't be a problem.
Perfect.
To follow up on that. Yeah. So with that, we'll go into questions. First one, from your experience, which is the best open source automated accessibility testing tool? Which tool are you using? Which tool are you recommending?
Mm-hmm. Oh, that's a great question. Yeah, so like I mentioned in some of the slides, we use Axe a lot. And that's something that I've found as being one of the best static analysis tools. And one of the great things about Axe is it's constantly evolving. When we update to new versions of it, we'll have new rules available depending on whether or not they've figured out how to add a new feature, or they might have updated to support a new ARIA guideline. The one thing with Axe is it takes a little bit of time to kind of learn the limitations of it. So for example, Axe can tell you if you have an input on the screen, it will warn you if you're not labeling that input properly. So, if somebody comes through with a screen reader, it might just say unlabeled input, and the user might not know that they need to type in their first name there. And Axe can warn you about that, but it can't warn you like if you put the wrong label in there or something that's not descriptive. And so there are some things that do require a bit of manual testing. Some of the other tools I'll mention that are helpful is for accessibility. We've also had a decent amount of luck doing some automatic testing with linting tools, actually. So tools that read our source code and warn us about certain things. So for React, there's a really good plugin. It's called, I think, JSX-A11Y, so JSX accessibility. And what that will do is make sure, so for example, if I have a React component and I add an on-click handler to it, but I don't add an on keyboard handler to it, that linting rule will come back and say, like, this is an error. You have a interactive element that doesn't have a keyboard control. So that's really helpful, kind of as a reminder, just reading the source code to do that. And we can do the same thing for some of our stuff in styles as well. So there's actually a StyleLint accessibility plugin. I think it's StyleLint-A11Y again. And for example, anytime in CSS that one of our developers adds a animation or a transition, it will come back and give us a warning and say, hey, make sure you add prefers reduced motion support for this. And so directly underneath it, it'll give us a little automatic prompt where we can click to add in a prefers reduced motion block, and we can, modify the animation or transition in any way to make that slightly less jarring. So those are like the three main tools we use for that. Some of our employees will also use the Microsoft Accessibility Essentials Chrome or Firefox extension to go through and do that, kind of do an audit of an individual screen. Things like that will be used a bit for marketing. And some people will also use the audit tab in Chrome or the accessibility tab in Firefox to take a look as well. I think the audit tab in Chrome actually uses Axe under the hood. So ideally that will line up with what we're seeing from our tests. But hopefully that answers your question. If you have any other questions about that kind of stuff, I'm happy to answer it here or on Twitter as well.
Next question, also about accessibility testing. What phase of testing is ideal for doing accessibility testing during functional or regression phase or other?
Yeah, that's a great question. So it actually kind of happens at multiple stages for us. So actually, accessibility testing is a decent amount of our unit and functional tests. So if you think about testing a button, I think a lot of engineers would kind of struggle immediately to think of like, what kind of tests do I do for this? People might go in and just start testing like, is the CSS I expect to be there? And that's really not a great test because you're basically testing the visuals without visually looking at the component. But what we can do is things like the accessibility testing. So if we have a component that has maybe a complex keyboard interaction, we can hit tab, tab, tab in WebDriver, enter, arrow keys, make sure that things behave properly. So that kind of gives us a base level as far as interaction. And then beyond that, we will just run Axe at some point after the functional tests have happened to make sure that you don't have any glaring incorrect roles or something on the component. And then we tend to do things like JAWS and NVDA testing and voiceover and screen reader testing further along in the process. So we'll do that more frequently on like full pages than on individual components. But it kind of all depends on how complicated the component is. So for something that's really big, like a table with a bunch of interactive elements in it, we might still bring that up with a screen reader to make sure that you can tab through the individual columns, and make sure that everything is labeled properly with the header on the top and the header on the left, those kind of things. But usually it's kind of something we test fairly early with some of the automation, but then it might be something we test manually at the end to make sure everything has the fit and finish that we're looking for. So hopefully that helps.
Next question. Some fonts don't look exactly the same on Linux and Mac. Have you encountered cross-platform typography issues in full-page mock testing?
Yeah, we definitely encounter some of that. We also could encounter maybe font spacing being a little different based on how that operating system handles ligatures or kerning or things like that. So there is a little bit of difference between there. We ideally want it to be as consistent as possible for our product across platform. So we'll do everything we can to make sure we're loading in the fonts we want to use and setting CSS properties that try to make the behavior consistent. But then also when we're visual testing some of that and we're using the grid, the different baseline screenshots for that will be different based on whatever operating system it's run on. So it won't necessarily give us an issue if the fonts look slightly different between Windows and Linux, but it will give us an issue if the font looked different yesterday on Linux than it does today. So there's a little bit of kind of flexibility there, but yeah, by and large, we'll just have to kind of step in and make sure our fonts are being loaded, and we might have to make some CSS tweaks to try to apply the fonts the way we want them to. So hopefully that answers your question. Thanks.
How are you ensuring the end user experience with respect to performance in terms of tools, process, other than checking bundle size?
Yeah, it's a great question. So once we get into actually testing performance of full screens, we actually have some things built into our page renders that track the amount of time it takes for the screen to render the first time, and that includes tracking how long it took to download the particular screen, as well as whatever React, which is the framework we use, thinks that it took to render the screen. So that's kind of how we'll benchmark how everything works, working together, and we can get some of those metrics from different end-to-end environments or production. So we can start to gauge, if users are having issues with render time on certain screens or on certain devices, and we can start to drill into testing that. But that's a little bit more on the analytics side, and unfortunately, I think any of our implementations for that are probably kind of custom. But I would definitely encourage, if you're using a JavaScript framework, you can probably get some information from it on how long it took the whole page to render, and you can use that. So hopefully that makes sense. I think well, one last piece I'd add to that is for a lot of these frameworks like Vue and React, they have dev tools that let you profile. And so you can use their dev tools to kind of profile render performance, but sometimes it might not be possible if it's a production build of the application, but if you have a debug build of the application, you might be able to tap into the same APIs that their dev tools use and kind of pull out some of the performance metrics as well and use that. So hopefully that helps.
Okay. Another question, do you have any strategy in performance testing to identify memory leaks on the client side?
Yeah, so that ties in a bit to the last question, because what we'll see with a memory leak is, so it can be kind of hard to detect. One thing that's really helpful is we do have some browser automation that kind of works its way through the entire product or certain paths of the product, and it does it all with the same browser session. So, if we have a Selenium setup that clicks through hundreds of screens in one session, we can kind of look at the beginning of the session, at the end of the session, and maybe get some idea of how much memory leaked, or if we start to get some warnings from Selenium. When it actually comes time to testing that, we will generally rely a bit on like the browser dev tools to take a look at that. So if we see that some tests going through a certain experience started seeing too much memory there, then maybe we'll go through the same experience manually with some of the Chrome or Firefox tools open to kind of gauge how memory is being used, and we'll add some breakpoints for different places where we're adding new objects to memory or manipulating data, and try to see where things are getting added, but maybe that reference is still around. So yeah, it's a bit low level, and it's a little bit hard to detect, but that's kind of the general workflow that we would use. So hopefully that makes sense.
So we are out of time, but let's take one last question. I hope I saved the best for last. Do you have any suggestions for how to migrate to a design system if we don't already have one?
Yeah, so that's something that I think a lot of people have questions about. We actually have done some things incrementally with our system. So we actually didn't have a lot of accessibility automation until like a little over a year ago for some of the core experiences. We were doing manual testing, but not necessarily using automated tools like Axe. And so as we've been rolling out the design system, we've been doing more testing on the design system side before it makes it into product, and then kind of expanding what tests we do on the product side. One thing we found, so when we added accessibility testing to the whole product as an automated step, there was a number of issues that were found immediately that it took us time to actually go through and address those. And so the way we structured a lot of our automation was it would only stop you from doing a release if you made anything worse than it was previously. But then, it basically would still allow you to keep things the same or improve it. And so over time, we just started gradually updating different pieces and kind of tracking that on different dashboards so that we could incrementally piece out and, fix different issues that we had. But if you're switching to a design system, like I definitely recommend trying out the design system CLI tool that I shared. Try building a component in there and moving some components over incrementally, and trying some of the testing strategies that I discussed earlier. So hopefully that makes sense.
We are out of time, unfortunately. We are a little bit over time. So before I let Tyler say his goodbyes, I want to thank everyone that joined us for this live session, and of course, thank Tyler for this really in-depth and hands-on presentation. As I mentioned before, the recording will be sent to you by end of day Monday, and I hope to see you at our next event.
Thank you so much for joining me. If you have any other questions, feel free to reach out on Twitter. I have the my Twitter handle and the LinkedIn username as well on there. So feel free to reach out if you have any further questions about the talk. Thank you.